Okay guys, welcome back. So on this first part, I want you to write down as many things as you can that you remember about right triangles. Okay? So we might start this list over here and we could say, I know a right triangle has 3 sides. It also has 3 angles. If it's a right triangle, I know there's a right angle. Okay, I'm going to give you about 30, 60 seconds and write down as many other things, and you can draw on the right triangle if you would like, but write down as many things as you can remember about this. Okay, so here are some additional things we're going to remember. We have 3 sides. The shortest side is always A, the medium side is B, and the longest side is C. We identify the longest side as across from the right angle. If you have not drawn in your right angle box, please do so now. We draw an arrow across to identify that that side is C. It's the line that slopes. It's always the line that slants. The line that slopes is called line C. We also know that C is the longest of the 3 sides. We also know it's called the hypotenuse. It's also called the diagonal. These are all great words. We said that there were 3 sides. Let's label this 3 angles. 1, 2, 3 angles. There's 3 sides, A, B, and C sides. We noted that on a right triangle it has a right angle. That right angle is equal to 90 degrees. Now, you may have forgotten this, but I'm going to remind you that these 3 angles, angles 1, measure of angle 1, plus the measure of angle 2, plus the measure of angle 3, the 3 interior angles of a triangle, do you remember how much that is? 180. There you go. 180 degrees inside. All 3 of these angles on the inside add up to 180. Now this is all stuff that you already know. There is this short line that goes up and down. I want you to write this word, vertical. And I also want you to write the word H-E-I-G-H-T. This is the height line. The vertical leg, in this case it's A, is the height line. And conversely down here, this would be the horizontal leg, the one that runs across the bottom, and it also has a special name for us, and it's called the baseline. Now, in this lesson over the next 6 to 8 weeks or so, and actually for the rest of your life, you're going to need to remember that this line that goes up and down is called the rise. And let's write that real big. And we also need to remember or learn that the leg, the horizontal leg, the baseline of the right triangle is called the run. Okay? And how you might remember that is that you run across the ground. The sun rises up and down, up and down. Okay, So another word, this is everything we have learned about these right triangles. There's a lot there, okay? But the two key pieces that we're going to talk about is this relationship between the rise and the run of these right triangles. And specifically, we're going to talk about this word, ratio. Okay, and we're going to give it a definition. A ratio, in this case, is a comparison of two numbers as a fraction. And that fraction that we're going to learn about is called rise over run. Rise over run. Let's talk about this lesson for today. In this lesson for today, we're going to be given two triangles, and we need to determine if these triangles are considered proportional or not. And so we're going to take the two ratios of the two triangles and we're going to determine whether or not they're equal. Okay? Remember, the key here is rise over run. So let's say I'm going to take the first triangle. Let's just say first and then we'll say second over here. And we want to put our numerator is going to be the rise. So if we look at this first triangle here, which of these numbers is the rise? The 4 or the 3? The 4. That's going to be our numerator, 4. Our run is going to be our denominator. In this case, it's a 3. Now, if we look at the second triangle, we're going to create an equivalent ratio, but we have to have the same numerator and the same denominator. Okay? Our rise on the second triangle is what? Perfect. 8. And our run on the second triangle is what? 6. Okay? Now, what's going to determine whether or not these two triangles here are proportional or not is whether or not the ratio of their rise over their run are equal. Okay? So that means that this is going to be true or what? False. This is going to be true or false. And we always are going to be using our calculators in the 8th grade. Okay, so we're going to put this in our calculator. We're just going to put this little equation. Remember, that we know it's an equation because there's an equal sign. And we can put this in our calculator to test whether this is true or false. So we're going to hit Control Divide, which 4 is my numerator and 3 is my denominator. Page right and press the equal sign, which is right down here next to the 7. Control Divide again, and we've got 8 over 6. And what do I get here? True. Okay, now if these are true, then we know that these two triangles are considered proportional. So please circle that word. And let's decide why this is. Why? Because both triangles share the same ratio of their height, quote, rise to, quote, run, which is their baseline. Okay, let's look at the second one. I have my first triangle and my second triangle. I'm going to create two ratios here and set them equal. Okay? My first, what do you notice about my first one? It's bigger than my second one. Doesn't matter here. Okay? I just need to make sure that my rise to my run for each ratio is in the right place. So on my first triangle, what is my rise? Is it the 15 or the 10? The 15, I'm going to make that my numerator. My run then is going to be 10. I set it equal to my second triangle. What's my rise on my second triangle? Is it 5 or 2? 5 over my run of 2. Okay. Now I got to do the same thing here. Control divide to put them in my calculator. 15 over 10 equals 5 over 2. And if it's false, guess what that's telling us?
It's non-proportional.
Non-proportional. Why? Because the two triangles do not share the same ratio between their rise to run.